All right, this is a practice problem with the definite integral, and we are intentionally not giving you the equation that represents what would have to be a piecewise function here. So we have a series of line segments going from negative 2 pi to 2 pi, and we're being told that this is the graph of the function f, and we're also being told that from 0 to pi, the definite integral equals k. So this net signed area in this triangle is equal to k. And we are going to use that to answer the questions below. So first of all, we want to find the definite integral from 0 to pi over 2. So we do have to assume some symmetry here. For example, we're going to assume that each of these triangles is congruent. So we have 4 congruent triangles, and we are going to assume that they are symmetric and can be divided by a vertical line that bisects the triangle at the vertex of each triangle. And so from 0 to pi over 2, my net signed area would be k over 2 because of that symmetry. I'll do one more with you, and then I'm going to have you pause this and try these on your own and come back here to check your responses. So from pi to 0, notice that my limits of integration are not written in the correct order. So we want to change the order to 0 to pi and pull out a negative sign. And so we're already told that the integral from 0 to pi is k. So with that negative sign, the answer to this one is negative k. All right, so please pause and do this work on your own and then come back to check. All right, let's take a look at some answers. The integral from negative pi over 2 to pi over 2 will be 0 because you're looking from here, and this section is a negative k over 2, up to here, and this section is a positive k over 2. So these two areas net out because they are signed negative and then positive. Number 4 is a bit tricky. This is a left shift of the function. So to get to 0 to pi, what we did was we left shifted the original function pi over 2. So the original function would have been from pi over 2 all the way over to 3 pi over 2, has now been shifted leftward, so it's from 0 to pi. So you've got this region here and this region here, and they net out to a 0 net signed area. The next one actually doesn't have to do with this graph at all. 2 is just a horizontal line, and so we are looking for a function with a height of 2 and a base of pi over 2 minus 0, so it's the area of a rectangle. 2 times pi over 2 equals pi. For number 6, what I did was take the 2 out here and just put it out in front of the integral. Then I can find the integral of f of x from 0 to pi over 2, which I already had up here in number 1, which was k over 2. Then we're multiplying it by 2, so we just get k. Number 7, this is going to be a horizontal compression. When you have a number here that is larger than 1, it is a horizontal compression, and this one's by a factor of 2. So what is now from 0 to pi on this integral was originally from 0 to pi over 2. So here you're talking about this entire region up here and this entire region down here, and they do net out to 0 due to the fact that we have congruent triangles, one above and one below the x-axis. Number 8, they're asking you to integrate from negative pi to 0. So that's going to be this region lying underneath the x-axis. The area of this region is k, and we have to sign it negative since it's below the x-axis, so our answer is negative k. Number 9, we're going to split into 2 integrals, and we already know that the integral of f from 0 to pi is k. That one is given. And then in number 5, we figured out that the integral, well, in the number 5, we worked on the integral from 0 to pi over 2. But a reminder that this here is the same horizontal line of y equals 2. So you've got a rectangle with a height of 2 and a base of pi. So that is your 2 pi component. So your answer here is just k plus 2 pi. Last 3. On number 10, what you're doing here is you're shifting right the original function by pi. So the new limits of integration from pi to 2 pi were the original limits from 0 to pi, which was the very first question or this is what we were given actually, that the integral is k. The average value of the function on 0 to pi just asks you to integrate from 0 to pi the function f, and then of course multiply by 1 divided by pi minus 0. So since we knew that this integral is k, we were given that, we're just dividing k by pi. And then the last question, they're asking us for f of pi over 2 in terms of k. Well, we know that the integral from 0 to pi is k, and that is also the area of this triangle. And of course, the area of this triangle will be 1/2 the base of pi times the height of f of pi over 2. So you see I wrote here that the area of the triangle is k, 1/2 times the base of pi times the height of f of pi over 2. So if I multiply both sides by 2 and then divide both sides by pi, I get that f of pi over 2 is 2k divided by pi.